Hello everyone. Welcome to the solution of LeetCode problem 1319 named number of operations to make network connected. In this problem, there are n computers numbered from 0 to n-1 which is connected by Ethernet cable connections, forming a network where connection I represents two value A of I and B of I. So here A of I and B of I represents a connection between the computers A of I and B of I. And any computers can reach any other computer directly or indirectly through the network. Now, you are given an initial computer network connections and you can extract certain cables between two directly connected computers and place them between any number of disconnected computers you want, so that we can make them directly connected. Now we have to return the minimum number of times we need to do this in order to make all of the computers connected. And if it is not possible, then we have to return -1. Now we can see in the first example, there are 4 nodes 0, 1, 2, 3, and 0, 1, and 2, they are connected to each other. And if we extract the wire between 1 and 2 and place it in between 1 and 3, then we can see that it is totally connected. So we have to do one operations. I hope you understood the problem statement. Now let's move on to the algorithm. So here, to understand the algorithm, we have taken the same example. Now we are given 4 node. The value of n is 4. So let's make 4 node, which is 0, then 1, then 2. After that, we have to make the last node, which is 3. So here, the connections array is 0, 1. That means there is a connection between nodes 0 and 1. So let's make the connection. And there is a connection between 0 and 2. So let's make the connection. And there is a connection between 1 and 2. Now let's make the connection. And if we discard this connection and make a connection between 1 and 3, the graph become connected or the computers become connected. But the question is, how can we solve this problem? At first, we have to check how many connections we have given, because if any graph has n number of nodes, and to make the graph completely connected, there should be at least n-1 edges should be given. So here there are 4 nodes and 3 connections are given. So this is okay. We can make the graph connected. But now the question is, how can we basically solve this problem? We can basically solve this problem by using the depth first search algorithm. So before jumping into the DFS, let's make an adjacency list. So in the adjacency list, we will trace which nodes is connected to which node. So here we can see that node 0 is initially connected to 1 and 2. Node 1 is connected with 0 and 2. Node 2 will connect it between 0 and 1. And node 3 is not connected to any other yet. So now basic intuition is, we have to calculate the number of connected components in the given graph, and the answer will be the number of connected components -1. So here we can see that in this graph we have given 2 connected components. That means there are 2 segregated graphs which is not connected to each other. So if we remove this connection and establish the connection between 1 and 3, the graph will become connected. So the basic intuition is, At first, we have to make an adjacency list. After that, we have to run a DFS to calculate the number of connected components in the graph. After that, the answer will be the number of connected components minus 1. So now let's dry run the example. Initially, let's start the DFS from this node 0. But before that, we have to make another vector which will track which node currently visited or not. Initially, let's make all of the 4 nodes as non-visited. Now 0, 1, 2, and 3. Okay. Now we are at this node 0. So make it visited. And from 0, we can go into 1 and 2. So let's look at the adjacency list of 0 and visit node 1. Now, from 1, make it 1 visited. And from 1, we can go to 0 or 2. So here we can see that 0 is already visited, so we cannot go 0. So let's move on to the 2. So from 1, we will get back to the 2 and make the 2 visited. Now from 2, we will get back to 0 and 1. But unfortunately, 0 and 1 is still visited. So the first iteration of the DFS will be started and ended into this portion of the graph. So it is the number of DFS 1. Again, in the adjacency list, as we have completed DFS into this 3 row, now we are at this node 3. But node 3 does not have any of the value in its adjacency list. That means we cannot visit any of the node from node 3. But still we are making a DFS call. So it is the second DFS call we can make. Now, the number of DFS call we have made is the number of component or number of connected component in the graph. So here we can see that we have made only 2 DFS call. So that means there are 2 connected component in this graph. And the answer will be 2 minus 1, which is the number of connected components minus 1 equal to 1. That means if we remove one wire from the first connected component and make the wire connected to the 1 and 3, in this case, both of the connected component will become connected. And this is the pretty straightforward algorithm. And overall time complexity of this algorithm is big O of n, where n is the number of nodes in the graph. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named makeConnected, which has integer n and a vector of connection named a. And if the size of the vector is less than n minus 1, we have to return minus 1, because in this case, the graph cannot be connected at all. After that, we have to take a vector to store the visited node. And initially, all of the node or all of the end node is unvisited. And we have to take a 2-dimensional grid, which is adjacency matrix of size n. Now let's build adjacency matrix for each of the connection given in the A. We have to insert or make the adjacency list here. That means the first element of any iteration, let's store it into a variable x, and the y will hold the second variable. So here, adjacency of x push back y or adjacency of y push back x. That means we have made the adjacency list here. After that, we have to run each of the a for loop in each of the given node. And if currently our node is not visited, we have to make a DFS call with this node and the corresponding adjacency list and visited list. So here in the DFS call, let's make the current node visited, and for each of the child in the adjacency list of the node, if the current child is not visited yet, we have to recursively call the DFS function with this child. After that, we have to increment the counter of answer. That means we have to increment the number of connected components we have got so far. Finally, we have to return answer -1. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.